Hello again, it's Mr. Wilson. So we're doing now Kinematics 2. All right, so the first 5-minute video was on Kinematics 1, and if you look at your review packet, we covered some of the things. I'm going to make sure I just reviewed the first video and I'll make sure that we cover the rest of it in Kinematics 2. So I talked about the 5 equations, I talked about the motion graphs and how to work with graphs in general. We'll talk more about graphs later. Now I want to talk to you a little bit about MKS. MKS is meat, kielbasa, and sausage. No, meters, kilograms, and seconds, you're saying, as I'm saying it, I bet, or before I did. Now, here's the deal. These are fundamental units. Fundamental units, if something is fundamental, it's like basic or very, very important. Same thing with these. These are the equation units that you plug into equations. So whenever you're looking for distance, you should use meters, kilograms for mass, and time as seconds. There are other things called derived units. Now derived units, you can take them for a long trip and derive, no. So derived units are things like meters per second for velocity or speed, meters per second squared for acceleration or acceleration due to gravity, newtons, which is mass times acceleration, and if you think about that, a newton must be equivalent to a kilogram per meter per, kilogram times meters per second squared, mass and acceleration. So those kind of things are derived units. So anything other than this is a derived unit. So you need to know about that. Next, speed versus velocity. Velocity, so, and then distance versus, sorry about the squeak of the marker. Mr. Norman would not have that. He would throw that marker like this and grab another one, so I'll do that. Versus displacement. That's what I've heard about him anyway. And so, and he would also use the English units, which we use the metric system because officially the United States is metric. I'm not sure if you knew that. And the rest of the world is too. Thank you. So, speed. Speed is going to be just how fast you go. Like how fast your speedometer says you're going. Like you should go, 30 miles per hour through town, 55 on the highway, gets better gas mileage, it's safer. Velocity would be how fast you're going with direction, like you're going to the east side, yo, okay? So, distance. Distance would be your straight line distance without direction. So it's a scalar. Scalars don't have direction. Vectors do have direction. You remember those, right? We'll talk about a list of vectors in a minute. So if you went 40 meters, 30 meters, your distance would be how much? 70 meters. Good. Your displacement is a direct vector, straight line measurement from start to finish. So that would be 3, 4, 5. That would be a 50 meters to the southeast. Southeast, okay? And you can figure this out by a squared plus b squared equals c squared. Good job. Vectors, you need to know your vectors. Vectors will move fast in a given direction. And you know that stands for which? Velocity, weight, and vectors will move momentum, which has the letter P for Patir. You remember that? Vectors will move fast, force, impulse, acceleration, and gravity, and displacement. We just talked about displacement is from start to finish. In a direct line from, the arrow would go from start to finish. Now, there's also force fields like electric fields, which you remember we'll talk more about, but those obey pants, and then magnetic fields obey ants. But they're force fields, so they're part of that vector group right there. And just looking over my list here, I believe that's all I wanted to cover for Kinematics 2. Nope, there's one more thing. You need to know about 1 gram is 1 penny. 1 kilogram is about 2.2 pounds. So if you have 100 kilograms like me, you're about 220 pounds, but it's 100 kilograms, so it's kind of more flattering. And also 1 meter is about 1 yard. So that, therefore, if you work out the numbers, 1 meter per second is about 2.2 miles per hour. Thank you.